So in today's lecture of integral equation, I will be doing application of Laplace transform along with some problems on Laplace transform, okay? Two examples I will be giving you all on this. So let me start with the application of Laplace transform. Application of Laplace transform, okay? Now we use Laplace transform to solve Volterra integral equation with convolution type kernel, okay? Now what you'll have to do is you'll have to consider y of x is equal to f of x plus integral from 0 to x k of x minus t y of t dt and take this as equation 1, okay? Now this implies what? Y of x is equal to now f of x plus, now this integral I am writing in terms of k star of y into x, okay, of x. Now what I will be doing is I will be taking Laplace transform on both the sides of this, okay? Let me do it on the next page. So Laplace of y of x for this one, Laplace of y of x, Laplace of f of x for this one, and plus Laplace of k star of y of x, okay? Now what is Laplace of y of x? Can you all tell me what is Laplace of y of x? See, in the previous video I have already given you all exact formulas, whatever it is. But in this lecture, I have given you all whatever the formulas will be required to solve the problem or the application, okay? Now what is Laplace of y of x is equal to? Nothing but y of p, right? So let me plug this value there. So that's what I have done it over here. Laplace of y of x is nothing but y of, where it was, yeah. So Laplace of y of x is nothing but y of p, okay? Now this is equal to what is Laplace of f of x will be nothing but f of p, right? Plus this I am going to write it as k of p. So Laplace of k is what? K of p, and Laplace of y of x is what? Y of p, okay? I have directly done this part. Now this is yp, right, as it is, minus, now I have taken this yp is there and here also yp is there, right? Now this is common, so I have taken this part the other side over here, so it will become minus k bar of p. So y of p minus k bar of p into y of p, okay? This I have taken it other side, so it will become like this. So now this is equal to what? F of p, this. Now y of p is common, take it outside, then write in the bracket 1 minus k bar of p. Now say if you all multiply, you all will get again the same thing only. Now this is equal to f of p, right? Now y of p, now this you all take it this side, the other side, upon this, f of p upon 1 minus k bar of p, okay? Now you all take Laplace transform on both the side, inverse Laplace transform on both the side, what you all are going to get is nothing but y of x. You all can try this. Okay, next I will be doing is, I will be starting with the problems now. That is this one. So y of x is equal to x square plus integral from 0 to x sine of x minus t y of t dt. Now how I am going to solve this is, like y of x is equal to x square plus in the bracket, how I am going to write this as, now we have done this proof, right? And how I have written this integral as this, no, k star of y of x. So similar way I will be writing this integral as sine of x sin x star y of x, okay? This. Now I have to taking Laplace transform on both the sides. So Laplace of y of x is equal to Laplace of x square plus Laplace of sin x star y of x, okay? This I have taken Laplace on both the side. So what is Laplace of y of x? Laplace of y of x is nothing but y of p. Now this is equal to what? Laplace of x square is what? Which formula to apply over here? How I got 2 raised to power of 2 upon p raised to power of 3 over here? I have to apply one formula over there, right? So I have to apply this formula, right? Laplace of x raised to power of n is equal to n factorial upon p raised to power of n plus 1. Okay, this I have to apply there. Okay, so over here I have applied that. So what it was like, Laplace of, here what is the x raised to power of 2 is there, right, upon n factorial. That means it is 2 factorial upon what it is, p raised to power of n plus 1. What is my n here? 2. So 2 plus 1 is what? Yeah, p raised to power of 2 plus 1 is nothing but, it will be giving me 2 upon p raised to power of 3. Okay, let me rub this part. That is for the explanation. So that's how I get this 2 upon p raised to power of 3. Plus, now what is Laplace of sine of, now plus Laplace of sine of x into Laplace of y of x, right? I'll do this on the next page. Now y of p, write it as it is. This part is equal to 2 upon p raised to power of 3 also. Write it as it is. Now plus 1 upon, now how I am getting this Laplace of sine of x is what? Let me see the formula first. So I have applied this formula. Laplace of sine of ax is equal to 1 upon p square plus a the whole square, right? So same way I will be applying there, okay? It is. So Laplace of sine of x, no it is, so it is like 1 of x. So 1 upon p square plus 1 square it was. So it is, I am writing it as p square plus 1. Okay. Now y of p, write it as it is, but this is also y of p is same. So what I'll do, I'll take this part the other side, okay, here, this side. So it will become, it is positive, right? Okay, right now it is positive. If you take it to the other side, it will become negative. So y of p minus 1 upon p raised to p square plus 1 into y of p is equal to this, write it as it is, 2 upon p raised to power of 3. Then y of p, take it outside because it's common, no, take it out. Then in the bracket put 1 minus 1 upon p square plus 1. See, if you all plug this inside, you all will get again the same thing, right? Now this is equal to 2 upon p raised to power of 3. Now what I have done over here, y of p, now this I have multiplied with this upon this entire thing, okay? Now here plus 1 minus 1 will get cancelled, and what will remain is nothing but y of p square upon p square plus 1 will remain is equal to 2 upon p raised to power of 3. Now this thing I will write it on the next page, okay? So let me write. Okay, so I have written it over here. Y of p into p square upon p square plus 1 is equal to 2 upon p raised to power of 3. Now y of p, now what I will do, what I have done over here, this I have multiplied it with this and this with this, okay? So it's like this basically. Okay, let me do this step. This step I am going to do, okay? This step I am going to solve it here. Now y of p is equal to 2y p square plus 1 upon p cube into p2, sorry. So it is what? p2 into p3, right? So I have done it like this. 2p square I have to multiply plus 2, and this thing is p raised to power of 5. Then what I have done is I have separated this part. Okay, y of p, this is equal to what? 2p the whole square upon, this is p5 plus 2 upon p raised to power of 5. I have done it over here, okay? Now y of p is equal to what? Now this term will get cancelled with this. So what will remain? Okay, so once this get cancelled, y of p is equal to 2 upon p raised to power of 3 will remain, right? Then plus 2 upon p raised to power of 5, write it as it is, okay? Now this part. Now what you all have to do is, you have to take inverse Laplace transform on both the side of this. Let me do it on the next page. Okay, so I have taken Laplace transform on both the side of this equation. Laplace transform for this along with this and this, okay? So Laplace inverse Laplace transform, inverse Laplace. So y of p is equal to inverse Laplace of 2 upon p raised to power of 3 plus inverse Laplace of 2 upon p raised to power of 5. So now what is the Laplace inverse of y of p? Inverse of this y of p is nothing. See this, inverse Laplace of y of p is nothing but y of x, okay? Let me plug it there. So it's nothing but y of x is equal to, take the 2 outside, okay? And Laplace inverse of 1 upon p cube plus 2. Again I have taken it outside. Then Laplace inverse Laplace of this 1 upon p raised to power of 5. Now this is equal to Laplace inverse. Now you have to balance it so that you will have seen the formula already. Go and check the formulas. And for 1 upon p raised to power of 3 is what? See, basically it's like what? X raised to power of n is there, suppose, okay? X raised to power of n is there. So this is equal to what? Laplace inverse of n factorial upon p raised to power of n plus 1, right? Something like this. So I have to get exactly, I have to balance and get this thing. So 2 Laplace inverse of 1 upon 2 factorial into 2 factorial upon p raised to power of 3. So if you get cancel this, what you will get? Again the same thing, right? Now plus twice 1 upon 4 factorial upon into 4 factorial upon p raised to power of 5. If you cancel it, what you will get? Same thing, no? Like this way. So I have done it like this. Now this is equal to what? Y of x is equal to, now take this outside, into x square. Now Laplace inverse Laplace of this is what? 2 factorial upon p raised to power of 3 is nothing but x square, no? What is my Laplace? Okay, so it will be x square, because Laplace inverse of what it is? 2 upon p raised to power of n plus 1. So even if you can write Laplace inverse of 2 upon p raised to power of 3. Sorry, 2 upon p raised to power of 3. So I have done it like this. So then again take this outside. And what you will get? Laplace, just wait a minute. This is Laplace inverse, okay? Just inverse Laplace. Just plug that, okay? I think I have not done it, okay? Anyways, just put Laplace inverse here also, inverse Laplace. And then this is x raised to power of 4 it will become, okay? This part. So now what you will do is, now this is y of x is equal to x square, because what will happen now? 2 will get cancelled. And what about this one? 4 factorial. 4 factorial is nothing but what? It is 4 into 3 into 2 into 1, right? Now which is nothing but 24. Now 2 upon 24 is what? 2 ones are, 2 ones are, 2 twos are. So 12 will remain. So that's what I have done it over here. 1 plus 1 upon 12 x raised to power of 4. Write it as it is, okay? And about this thing, 4 factorial upon p raised to power of 5, have you all understood this part? So basically the formula will look like this for this one, okay? Laplace inverse of 4 upon p raised to power of 5 will be what? X raised to power of 4. That's what I have got it like this, okay? Now let me do the next problem, the other one. So I'll turn. So now I will be dealing with this problem, second one, the last example of this today's lecture. X is equal to integral from 0 to x e raised to power of x minus t y of t dt. Okay, now x is equal to, now how I'm going to write this integral as e raised to power of x star y of x, right? From that thing I'm writing it from here. Okay, like how I'm writing this kernel as k star y of x, like similar way I am doing it for that problem. Okay, so same thing I've done it over here also, similar way. Okay, e raised to power of x star of y of x. Now I have to take the Laplace transform on both the side. So what I'm going to get is Laplace of x is equal to Laplace of transform of this e raised to power of x star into y of this thing y of x. Okay, now what is Laplace of x? Is nothing but 1 upon p the whole square. Now this is equal to what? Laplace of e raised to power of x into Laplace of y of x. Okay, now what is, now this part, write it as it is. 1 upon p the whole square is equal to, you all have understood now what is this? Laplace of x, what is L of x? Is equal to, this is considered to be as 1, okay, raised to power of. So it is 1 factorial upon what? P raised to power of 1 plus 1. That is n plus 1. So n is what? 1 here. So what I will get is 1 upon p raised to power of 2. Okay. Now what is this? 1 upon p square is equal to 1 upon p minus 1 I am getting. So here L of e raised to power of, suppose L of e raised to power of ax, but here my a is what? My a is 1 here, right? Here, this 1. Okay. So I will be writing this on the next page. Let me do this formula part. So L of e raised to power of, Laplace of e raised to power of x is nothing but 1 upon p minus 8 was, right? But here what is there? 1 is there. So I have to plug 1. Okay. And what is my y of x? Laplace of y of x is nothing but y of p. Okay. So these formulas I have given to you all here. Okay. You can just go through these formulas. See, Laplace of e raised to power of x is equal to 1 upon p minus a. So y of p, this y of p, write it as it is. Now I have taken this here, this into this. Okay. Now p minus 1 upon p the whole square. Now y of p is equal to, now I have separated this part. Okay, let me rub this part and to show you all, like p minus 1, okay, and then p square, and for this one also, then what will happen? This term will get cancelled, right? So over here also I have done, no? So this term will get cancelled. So what will remain? 1 upon p. Y of p is equal to 1 upon p minus 1 upon p the whole square will remain. Now I have to take inverse Laplace transform on both the side of this. So Laplace inverse of y of p of this and is equal to Laplace inverse of this and this, okay, minus Laplace inverse of 1 upon p the whole square. So what is this? Laplace inverse of y of p, y of x. Y of p is nothing but y of x. That's what I have written here. Y of x is equal to, what is Laplace inverse of 1 upon p? Laplace inverse of 1 upon p is nothing but 1. So that's what I have plugged it over here. Minus x. Laplace inverse of 1 upon p square is what? I have to apply this formula over there, which I have already given to you all, okay? And with this I am done with today's lecture. I hope you all have understood today's lecture, and thanks for watching. If you have not understood any of today's concept, you all can comment below, okay?